The first activity, What is Gravity?, introduces the concept of gravity and air resistance. First, children will receive an introduction by participating in a teacher-led read-aloud. Afterwards, they will use the picture and word cards with fun facts to continue building that foundation. These picture cards encourage a discussion of gravity's impact on our everyday lives. The back of each card contains a fun fact and questions to make the concept of gravity more meaningful and familiar. Now it is time for the children to experience the first experiment related to gravity and air resistance. Children will predict before testing which piece of paper will fall to the floor the fastest. One piece is flat and the other piece is crumpled. Two children will hold the paper the same distance from the floor and drop them at the same time. In the first part of this activity, children will compare a crumpled piece of paper with a flat piece of paper, predicting and testing which falls to the floor the fastest. Children will record their predictions by drawing the two pieces of paper on their prediction page and marking which one they think will fall fastest. They will share their observations and discuss their predictions before testing. Children will be guided to conclude that air resistance is another invisible force that works with gravity to determine how fast objects fall to the floor. As children experiment, you may wish to record data on a board or on chart paper as well. After the experiment has been completed, ask children questions such as,
which paper reached the ground first? Why do you think that is? Why did one piece move faster than the other? What can we do to make the paper fall even faster? This is our prediction page, and on my prediction page, I drew a picture of the large Taj. Remember? I drew a picture of the whole piece of paper, and I drew a picture of the smaller piece of paper. And then you're going to predict which paper you think will hit the floor first. If we drop them both from the same place, which paper do you think will hit the floor first?
No, don't
do it yet. Can't do it yet. So I'm going to give you your prediction page, and I want you to draw the big paper and the little paper.
This is like gravity.
Yeah, you can draw now. Lily, you can draw over here or you can draw over there. It's totally up to you. There you go. So you're going to draw your large piece of paper and your small piece of paper. And you're just going to draw them under the crayon. You know what? Your paper can look like anything you want it to. You can draw it any way you want. I just drew mine in squares and rectangles.
I'm done.
That's fine. That's perfect.
I can do numbers.
You're going to do 1 and 2. That's good, Mystery. So Cameron, put an X in this column to show which paper you think is going to fall to the ground first. Do you think the big paper will fall first or the small paper?
The small paper's in front. So I would go for the small one.
You think the small one's going to hit the ground first? What do you think, Mystery? Do you think the big paper will hit the floor first or the small paper?
Big paper.
The big paper? What do you think, Taj? Do you think the big paper will land first or the small paper?
The big paper.
You think so?
The next part of this activity has the children replace paper with other objects. For example, a small rock, a rubber ball, a plastic figure, or a crayon. The children will then make their predictions as they did in part 1. Two children will hold an object, then they will drop them at the same time. The children will then share their observations and their predictions, and as in part 1, children will be guided to determine how air resistance and gravity impact how fast objects fall to the floor.
So why don't you hold your hands in front of you, just straight out.
I know which one's gonna make it. I
Can
tried
you
it.
scoot back just a tiny bit? Okay, boys and girls, are we ready to count back from 3? Ready, Mystery? Ready, Taj? 3, 2, 1.
I know which one made it.
Which one landed first?
Since the
Cameron.
big one's right down and that one's right down.
You think that's
So
what
that
makes...
was the one win. Let me
So?
see. Who won?
We don't know. We're going to have to do it again.
I think both of them landed.
It did seem like they landed very close to each other. How about I'll go way up in the air and do it, okay? You ready? You ready?
Drop it.
Do you want to come over, Taj and Mystery, so you can see better? Uh-oh. Gravity pulled my papers down. Okay, scoot back so they don't land on you. Ready? Here we go.
Hey, the little one fell first.
It did.
I
Which
knew
one landed
it.
first, Taj?
The little one.
All right.
The little one.
Cameron, which one did you predict? Did you predict the small piece or the large piece?
Small piece.
Lily, check out your prediction. Which one did you pick?
I picked it.
You picked it? Point to the one that's it.
It.
With your...
It's on the bottom.
You're reading to me. I thought you were telling me which paper fell first. Taj, you you've learned so much since last time I saw you.
And
I can tell.
I think the little one is better and the big one not.
Do you think there's a reason why the folded up paper falls faster than the big paper?
Because that one has a lot of air.
Give me a knuckle. That was an amazing answer.
Wow.
Lily was really listening well. Do you guys remember what force it is that makes the paper fall to the ground?
And
Do you remember what that word
is?
is?
The little paper went down because it was too strong for it to go down.
The paper was?
Look at Cameron. It went down
Cameron,
because it was too heavy for the air to make it fell really slow. And the big one had more, and the big paper didn't have heavy.
The big paper didn't feel as heavy, and it was wider, so the air had more to work with. So it fell slower. You said it exactly right, Lily.
Please take a moment at this point in the lesson to review gravity using pictures. The concept of gravity is sometimes difficult for young children to understand because it is not visible. Using the picture cards, ask the children to predict what would happen if no gravity existed.
So if there was no gravity, instead of sitting on chairs, we'd just be floating up in the air. That'd be kind of fun, wouldn't it?
Ooh, yeah. Like Superman does.
Yeah, but gravity helps us stay on the ground. What would happen if there was no gravity for this ball?
It will fall.
If there was no gravity, it would float. It would just hang in the air because gravity pulls us down to the ground.
Now it is time to test gravity's effect in water. Children will test the effect of dropping objects into two tubes. One of the tubes will be left filled with just air, and the other will be filled with water. Children will predict in which tube their object will fall the fastest, and record their prediction by completing another prediction page. As you count the time that each object takes to fall, consider recording the number of seconds on a board or on chart paper to illuminate later discussion. After testing, the children will conclude whether objects fell faster in the tube containing only air or the tube filled with water. Spend some time throughout the discussion to determine whether air or water provides more resistance and how gravity interacts with the objects, air, and water. Ask questions such as,
Do you think the objects fall faster in air or in water? Why do you think that is? Why did some objects fall faster than others? Which fell the fastest? How do you think that gravity works differently in the water?
Do
you think your teddy bear will fall faster in the water or in the air? Do you see at the top of your prediction page? What do you think? Which tube is this? Does this one have water or air in it?
Water.
Yes. And this one has what in it?
Air.
Yes. So put an X. Put an X next under the tube that you think your object will fall faster in.
The water.
You think it'll fall faster in water? And then boys and girls, we're gonna count. So when she lets go, we'll help her count to drop the teddy bear, and then we'll count the number of seconds it takes for the teddy bear to get to the bottom. Okay?
Okay.
Okay. We'll see if gravity works in water. All right? If this teddy bear is wearing the same color you are. All right, so why don't you put your teddy bear, let's actually start with the one that just has air in it. The invisible air. So we'll count back from 3 and then we'll say drop and you drop, okay? And then we have to count again to see if we can count how many seconds it takes for it to go. Ready? 3, 2, 1, drop. 1. Oh.
She didn't make it more fast.
I couldn't even get 1 second. Did you guys count?
Yes.
1 second? I just put that it took 1 second for our teddy bear to fall? This is our empty one, and this is our one that has water in it. And it took 1 second for the teddy bear to fall. Okay, Mystery, I'm going to have you drop the teddy bear over the one with water. Let's help her count again from 3, okay?
3,
Hold it
2,
over.
1.
Hold on, she's not ready. Ready? 3, 2, 1, drop. 1, 1,000.
Down has gravity.
What happened?
It has gravity.
Tosh,
It has
I like your laugh,
gravity.
but let's have a more inside laugh.
It has gravity. I knew it.
It has gravity. Gravity makes things fall,
Yeah, but I
though.
go.
So what happened to the teddy bear?
It came, then it came back up.
It didn't, it
Can I
floated.
try now?
No, because you're not sitting. All right, Mr. Taj, I'm going to have you go next. Are you ready? All right, Taj, we're going to start over the one that has air, and then we'll do the one with water. So everybody help him count. 3, 2, 1, drop. I didn't even get 1 second out.
Yeah, it
Will you count, drop it over the water? Ready? 3, 2.
is.
We didn't get all the way down our countdown, but what's happened to the ball?
Has gravity.
It's not sinking. Do you know what happens, what it's called when something doesn't sink to the bottom in water?
Let's use shell.
It's
Let's
called
use
floating.
the shell.
All right, everybody, when I say drop, you drop the rock over the air tube, okay? 3, 2, 1, drop. Wow! Well, that was fast. Let's see what happens in the water.
Yeah.
3, 2, 1, drop.
It's too small.
It went all the way to the
so
bottom.
fast.
I wonder why that one was different. Let's get the rock out. Now, I'm going to drop the rock this time, and I want you guys to try to count the number of seconds it takes for the rock to get to the bottom. You think we can try?
Yeah.
Okay.
Yeah.
So I'm going to drop it, and let's count how many seconds it takes for the rock to fall. Because we still want to see if the water goes any faster than the air. Okay? In the air, it took less than 1 second. All right. 1.
One minute. Can I try 2?
We're going to try the seashell. All right, Lily, will you pass me the empty tube? You guys did an excellent job with our experiment. Were your predictions right? Did you choose air, Tosh? You thought it would fall faster in the air?
Yes.
What about you, Lily? Did you mark either air or water?
Yes.
You marked air. Cameron, I can't see your face. What did you mark, Cameron? Do you remember? Did you mark air or water? Which one it would travel faster in?
What a nail.
Is this one yours? Oh, you marked one for your ball and a different one for the rock. That was a good prediction. Are you gonna, did you fold yours up so you can see if which one would fall faster?
Look.
What did you want me to see?
I'm a ball.
Your ball, and you said it would fall faster in the air.
No,
And
Mom,
you
this
made
one got
the correct
wet.
prediction. Give me a
This
knuckle.
one got wet.
I don't want your crayon, I want a knuckle.
I got
Let me have your crayon.
High
Thank you.
five. Can I take a high five?
I'll take a high five. Thank